Hello guys, we have another video for you again today just on my channel. Is Math Time Questions and Answer, a channel that provides you insights with questions that gives you headache at school. Today's question, we are going to talk about partial fraction, and it's taken from Cameroon GCE board 2021 question 1 Roman 2. It says that we should express 5x on x plus 3 into x minus 2 into partial fraction. So we can see that this is a fraction, and they want us to split this fraction into two or more other fractions. And if we look at the denominator, we see that the denominator is linear. For us to divide this fraction into two or more other fractions, we are going to look at the nature of the denominator. If the denominator is a quadratic, if the denominator is a repeated factor, or if the denominator is a combination of repeated linear and quadratic functions, it has different ways in which we can transform it into partial fractions. But since this fraction has a denominator of linear factors, we can express it into partial fractions simply using two methods. So the first method we are going to use here is the general method that we always use when we have want to convert a fraction into partial fraction. So in this case, we have the fraction 5x on x plus 3 into x minus 2. So because the denominator is linear, we are expecting, and it has two products, so we have two partial fractions, which one will be what? X plus 3, and the other will be x minus 2. So because it has a linear denominator, the numerator must be constants. So we'll affix a constant at each numerator. So in this case, we say that the fractions can be a on x plus 3 plus b on x minus 2. Because the denominator are linear, we must have constants at the numerator. In this case, we can look for the LCM of the fractions on the right. So the LCM normally are x plus 3 and x minus 2. So x plus 3 will go into x plus 3 and x minus 2 times a will give us a into x minus 2, plus x minus 2 will go into x minus 2, so we'll be left with x plus 3. So we'll have plus b into x plus 3. Now we can see that when we compare the right hand side and the left hand side of this equation, we can see that the denominators are equal, so we must equate the numerators, and the numerators are 5x on the left hand side, and the numerator here are a into x minus 2 plus b into x plus 3. So those must be equal. So therefore we'll say that 5x should be equal to a into x minus 2 plus b into x plus 3. So in this case, we will need to open up the bracket of the terms on the right. So we are going to have x times a will be ax minus 2 times a will be 2a, plus b times x will be bx, plus 3 times b will be 3b. So we are going to have 5x equals to ax minus 2a plus bx plus 3b. Now the next thing we are going to do here is to equate the coefficients of terms on the right hand side and terms on the left hand side. So the very first coefficient we are going to equate here are the constants. Is there any constant on the left hand side? No, so I fix a 0. Equals to, is there any constant on the right hand side? Yes, minus 2a is a constant because it has no value, it has no x attached to it, and 3b is another constant. It has no s attached to it, so 0 is equals to minus 2a plus 3b. And when we are equating the values for x, on the left hand side we are going to have 5, and on the right hand side what has s is a and b has x, so we are going to have a plus b equals to 5. Now we cannot use elimination method here, but we can use substitution. So but I like using elimination, so we are going to multiply the equation 1 times 1 and equation 2 times 2, so that the coefficients of a will be equal, and then we can eliminate a. So if we multiply them like that, we are going to have equation 1 will be transformed into 1 times 0, 1 times minus 2 plus 1 times 3, which will leave that unchanged. But equation 2 is going to change. 2 times 5, which is 10, 2 times a, which is 2a, and 2 times b, which is 2b, to give us that. Now if we add equation 1 and equation 2, we are going to eliminate a. So if we add those, we are going to have 0 plus 10, which is 10, is equals to minus 2a plus 2a, which is 0, and 3 plus 2 is 5, what? B. So it's equals to 5b. If we divide both sides by 5, we are going to have b equals to 2. Now we can substitute b equals to 2 in equation 1, equation 2, equation 3, or equation 4. So I've decided that I will substitute b equals to 2 in equation 2, because equation 2 is very simple, so it will be easier for us to get the value of a. And equation 2 says that 5 is equals to a plus b. We are looking for a because we have known b already, so we'll take b to the other side. Its sign changes to negative, so 5 minus b equals to a, but b is equals to 2, so 5 minus 2 is equals to a, and a is equals to 3. So we have gotten the value of a and b. So the partial fraction that we need will be going into these partial fractions that we have gotten and replacing the value of a and b with 2 and 3 and 2 respectively for a and b. So we are going to have that partial fraction 5 on x divided by x plus 3 and x minus 2 will be equals to 3 in over x plus 3 plus 2 over x minus 2. So that's how we handle those type of situation. Now there is another method that we mostly call the cover-up method that we can use to evaluate this situation. Okay, let's look into the method. We are going to have the same fraction that we want us to be break it down into partial fraction. So we are going to see have 5x into x plus 3 into x minus 2 should be equals to, the denominator is linear, so we are going to have constant at the numerator, should be equals to a on x plus 3 plus b on x minus 2. So if we take the LCM again, we are going to have x plus 3 and x minus 2, and x plus 3 will cancel x plus 3, will be left with a into x minus 2 plus x minus 2 will cancel x minus 2, will be left with b into x plus 3. In this case again, we are going to equate the numerators because the denominators are equal. So 5x is equal to a into x minus 2 into b into x plus 3. So in this case again, we are going to eliminate x for either a or for b. We choose anyone to begin with. So in this case, we are going to eliminate x in the case of a. So if we are going to eliminate a, then we are going to look for a value of x that if we substitute here, minus 2 will give us 0, so that 0 times a will give us 0, and then we'll eliminate a. So in that case, x should be 2. So for x equals to 2, we are going to have 5 times 2, which is 5 times 2 equals to a into 2 minus 2 plus b into 2 plus 3, sorry. So 5 times 2 is 10, 2 minus 2 is 0, 0 times a is 0, so a is gone. That's why we say that x equals to 2. And b into 2 plus 5. So in that case, we are going to have 10 equals to 5 times b. So 2 plus 3 is 5, and 5 times b. So we can divide both sides by 5 to give us b equals to 2. And again, for the section containing b, we need to eliminate b. So we can look for a value of x that if we substitute there, b will become 0, and that value of x should be minus 3, so that minus 3 plus 3 will be 0, and 0 times b will be b, so b is gone. So we are going to have, for x equals to minus 3, we are going to have 5 into minus 3 equals to a minus 3 minus 2, and minus 3 plus 3 is 0, so 0 times b is gone. Needless to put it there. So 5 times minus 3 is minus 15, and minus 3 minus 2 is minus 5. So if we divide again all through by minus 5, we are going to have a equals to 3, and those are the same values we had for the first method. So guys, that's how we handle partial fractions with linear denominators. We are going to see other problems with quadratic denominators or repeated denominators, and I'm going to explain how to handle such situations. So stay with me and remain blessed. Don't forget to subscribe to my channel, like and share my videos. Bye bye.